Alright, I know the last video went kind of long about how to get completing the square, but we're going to review that a little bit here at the first part of this video. So this is about graphing with Vertex Form, and it'll look very similar to what the other work was. So just remember that you're bringing a lot of new skills together, developed over just the past couple of weeks. Stick with it. I know that it's really hard sometimes when there's a lot of new. Review some of the past week's lessons if you need to, and attend the Zoom meetings. I'll demonstrate how to do all of this again, and you can ask pointed questions. If you need, please do email your teacher. I don't expect you to have complete mastery, but I do expect you to watch the videos, so please do your best, and thanks for watching. I know some of them are pretty long. Alright, so just a quick review, the parts of a graph, particularly a quadratic, is we've got the roots, it's where they cross the x-axis. We've got the vertex, which is the highest or the lowest point, and it's the spot all the way at the top, and we can actually give it a specific point. And then we have the y-intercept, and the y-intercept is the same y-intercept you're very familiar with. Just know that the line of symmetry goes through the vertex, and so that can be very helpful as well. Alright, so when we were talking about completing the square, we're looking at the form where the a value is 0, so it's really just x squared plus bx plus c. We took this bx part, and there's a c kind of somewhere off to the side. We've taken that b, we've cut it in half, and we've moved half of it over so that we know that the length of this side is b over 2, or half of b, and the length of this is half of b as well, because we took the b and we cut it in half. And that leaves us this little corner that has dimensions of half of b and half of b. And if we wanted to complete this square, we'd have to add in half of b and half of b, but we can't just add in half of b. We've got to add in half of b. Well, it's half of b squared, right? Because it's a square. And we also have to take it away. We have to take away half of b squared. And when we do that, you get this perfect square, and we can write it in completing the square form. The trick that we learned was that we take the b term, in this case it's 8, and we cut it in half, so that's b over 2, that's half of b, and then we square it. So we take the half of the b, and we raise it to the power of 2. So in this case it's 4 squared is 16. And then we add and subtract that in. So instead of x squared plus 8x plus 10, it's x squared, here I'm going to do it in a different color, it's x squared plus 8x, leave some space, plus 10, and then we have to add in 16 and take away 16, because this part is the perfect square part, the x plus 4 squared, and this other stuff is the leftovers, minus 6. Well, when we write it in this format, I'm going to actually bring it down here, and we write it with y equals x plus 4 squared minus 6. This is called vertex form. And I'll talk a little bit about why this is called vertex form in just a moment, because these two numbers in here actually tell you parts of the vertex on the graph. So we'll practice. We just did this one on the previous slide, so I'm going to just skip past this. So we've got them in three forms. We've got standard form, we've got factored form, which we talked about a couple weeks ago, and we've got vertex form. Well, the standard form actually tells us about our y-intercept. So this right here at -6, that's our y-intercept. It's right there. Our factored form, when we set it equal to 0 and then solve, we find out that either x plus 1 equals 0, and so that makes x equal -1. So that's one option. So x is either going to equal -1, or, remember the other option was x minus 3 equals 0. So we're going to add 3 to both sides. X equals 3. So either x equals -1 or x equals 3. There's our other spot. So we use the standard form to get the y-intercept, the factored form to get the roots, or the x-intercept, and vertex form is going to be the vertex. It's going to tell us the vertex. Now remember, the vertex happens on the line of symmetry, and the line of symmetry here is at 1. Well, where in here do you see 1? Well, you see 1 right there. It actually looks like -1, but check it out. It happens opposite of where we would expect it. So we'd think it's not at -1, it's at 1. So it's really the opposite of whatever's in here. And then at -8. Well, if the curve has to go down here, it's got to go through -8. So I'm going to plot that point on the graph. 1, -8. And now we have a much clearer picture of where this graph is going to go, because it's got to go through each of these points. It's got to go through that x-intercept. It has to go through this red y-intercept that we created. It's got to have a peak at the vertex, and then it's going to come back up, and it's going to go through the other x-intercept. So I hope you can see that this point and this point give us the vertex down here, and that each way of writing each equation tells us a little bit different pieces of story about the function and how it's graphed. So here's a quick review of everything. I strongly recommend that you pause the video and kind of take a note of this, because we have a bunch of different forms for graphing. This is standard form, and from this we get the y-intercept by plugging in x equals 0, because if x is 0, it is the y-intercept, and that's the same as it was in Algebra 1. And ultimately it becomes just this last number, whatever this last number is. And we can find the roots of this same function by factoring it, and when we set it equal to 0, we'll use the zero product property here to find the roots. And then we can use completing the square to get it into vertex form, and we think the opposite of the inside, so in this case it's going to be the opposite of -1, so +1, and it's going to be the outside, 4, -4. So for this quadratic, the vertex happens at that point. We'll do a couple of examples, but please pause the video and write these down, because this is where all of these concepts are leading us to, is graphing these functions. So I've already factored this and put it into vertex form for you. And remember that the x-intercept is when x equals 0, so 0 squared minus 2 times 0, these are both 0, is -3. So our x-intercept is at -3. We use the zero product property because the height of the function, the y value at the x-intercepts, the height is 0. The y value equals 0. So we set it equal to 0 to find, if x plus 1 equals 0 and x minus 3 equals 0, then x has to be -1 or x has to be +3. I think we just did this actually. It's -1, and +3, and our y-intercept happens at the opposite at 1, 1, and -4. 1 and -4. We can start graphing this equation, because we know that it has to go through those points. It has to have a vertex at my vertex point, and we're done, right? So I hope that you see it's the opposite of this. So instead of -1, it's +1, and it's just the regular outside to get this vertex point at the bottom. We'll do one more because I think it's important. So remember, the y-intercept is where the x value is 0. So 0 squared minus 8 times 0 plus 12 is +12. So our our y-intercept is 12. Our x-intercept happens when each of these is set equal to 0. So add 2 to both sides. X equals 2 is one of them. So x equals 2 is one of them. and x, set this equal to 0, so plus 6, so x equals 6, and 6 is our other one. So you can start to see, oh, it's probably going to start up here and go down, and our vertex is going to be somewhere down here. Let's hope. So remember, it's the opposite of the inside, so it's going to be 4, and it's just copy the outside, -4. And does that put us in the right spot? When x is 4 and y is -4, it puts us right there. That kind of looks right. So I'm going to plot that point. Plot that point, 4, -4, and you can see it's not going to be perfect, but it's way better than we were able to do earlier in the year just by guessing. So it's got to go through the root, hit the vertex, curve back up, and go off to infinity again. So go ahead and pause the video. I want you to practice writing these in vertex form and factored form, and then decide what is the vertex and what are the roots. After you pause it, come back and watch this again, and I want to see that you can check your answers as you go for how did you do. So this is a good way to check your understanding. Hopefully you've taken a moment to check your understanding and you've answered these questions. What is the vertex based on the vertex form, and what are the roots based on the factored form? So remember, we've got to complete the square, which means that we've got to take the b value. The b value here is 4. Cut it in half, so half of 4 is 2, and then add and subtract, square it, so b over 2, half of b quantity squared equals 2 squared is 4. So we're going to take x squared plus 4x. We're going to move the 3 over just a little bit. We have to add 4 in and subtract 4. When we factor this, we get x plus 2 times x plus 2. And when we copy this, or write this down, we get -1. And this ends up being x plus 2 quantity squared minus 1. So y equals x plus 2 quantity squared minus 1. Well, what's the vertex? Well, it's the opposite of the inside. The vertex is -2, and the y-coordinate of the vertex is -1, because it's the opposite of the inside, and then it's just copying the outside. Well, factored form is going to tell us what the roots are. So we have to factor. Factoring, that's not a big enough box, is something we studied a couple weeks ago. So we're looking for things that multiply to 3 that add up to 4x. So things that multiply to 3, well, 1 times 3 is 3, so 1x and 3x, and factor out common terms. So we got an x here, a 3, that has to be 1 and x. So the factored form is y equals x plus 3 and x plus 1. To find the roots, we set it equal to 0. So either x plus 3 equals 0 or x plus 1 equals 0. And then we solve. So -3 on both sides. X equals -3, so that's one of the roots. -1 on both sides, x equals -1. That's our other root. So our roots are where it crosses the x-intercept, and we're going to graph this really quickly. So we know that the vertex comes from vertex form. Remember that this tells us our vertex is at -2 and -1, so -2, -1 is going to happen right there. Our factored form tells us our roots at x equals -1 and x equals -3. So -1 and -3. And our y-intercept, our y-intercept is going to come from our standard form, which in this case is 3. So 1, 2, 3. And then we can use those 3 points, those several points, to kind of get a good sketch of this graph. And it's never going to be perfect because we're doing it by hand, but we can get really, really close. I hope this video kind of simplified the process for why we were doing things and kind of brings it all together. The next video is about how the quadratic formula comes to be, and it's a lot more complex. But for now, this is the core, this is the meat. I want you to practice this a lot as you move forward. Thanks for watching this entire video. Please email if you have any questions and attend the Zoom meeting. I'm happy to work on past work if you need it as well.